What is matter? Matter is a physical substance that has mass and takes up space. There are two types of matter, living and non-living. For the living, we have tree and maybe cats. For non-living, we can have a basket and a pot. Matter is made out of small particles called atoms. An atom can only be seen through a microscope. Matter is material used to make objects which take up space. Let's take a chair. A wood is made up of atoms. Small atoms built together, they form matter. So atoms are building blocks of matter. Many atoms make up matter. Let's talk about the properties of matter. Matter is strong and resists bending like bricks and rocks. Matter can conduct heat like metals. Brittle material breaks easily like plastic. Malleable can be easily formed into different shapes, clays and doughs. Magnetic material have magnetic fields like iron, have density which is mass per unit, and they have boiling and melting points. Matter can be a mixture or a pure substance. What is an atom? Atom is the smallest unit of matter and it is made up of three subatomic particles, which are protons, which are positively charged, neutrons, which are neutral, neither positive or negatively charged, and electrons, which are negatively charged. Let's take this atom. Inside is a nucleus. Nucleus has protons and neutrons. The outer layer has electrons, which are negatively charged. And the outer layer, the third layer, has valency electrons. Matter can either be a mixture or a pure substance. And a mixture can be homogeneous or heterogeneous. A pure substance can be made up of elements and a compound. Elements are metals and are magnetic. Compounds are non-metals and non-magnetic. If a container is only filled with one type of element or filled with only one type of compound, that is a pure substance. So elements and compounds make up pure substance. A compound is when two or more different atoms are bonded together. Atoms in the same group, like oxygen and hydrogen. Let's look at these three boxes. We have a pure substance, a compound, and a mixture. In the first box, we have nitrogen only. There is only one element, which means one element is a pure substance. We have a compound, a combination of hydrogen and oxygen. They are in the same group, so they make a compound, which is also a pure substance. And we have a mixture. We have nitrogen and carbon. A box with the same element is a pure substance. Homogeneous mixture. You can only see one thing when you look at the mixture: coffee. Heterogeneous mixture, you can see what has been mixed inside the mixture, like cereal and milk. What is a valency? The combining capacity of an atom is known as a valency, meaning the number of bonds that an atom can form as part of a compound is expressed by the valency of the element. Valency electrons are the electrons present in the outermost shell of an atom. The octet rule. Atoms tend to gain, lose, or shed electrons to achieve a stable electron configuration similar to noble gases. Noble gases have a full-filled outer shell making them least reactive. This part of the periodic table represent noble gases, helium, neon, and the rest. Those noble gases are fully surrounded when we draw the Lewis diagram. What we have here is called the periodic table of elements. The red, orange, yellow, and this green shaded elements are called metals. This light blue shaded elements are called metalloid, which means they're semi-metals. From carbon going straight, this blue and this purple rows are called non-metals. All these elements in this first group have a valency of +1. This one a valency of a +2, and this one's a valency of a +3. This one positive, -4. This ones have a -3. This ones have a -2, and this ones have a -1. How to find valency electrons? Let's take beryllium, for instance. It's here in group 2. So we start 1 and 2 will be its valency, and 1, 2 will be its valency electron. The first 2 valencies that we had counted will come here. And then the third one, which is the second one, which is from 1 to 2, will be on the outer. That will be the valency electrons. So beryllium has valency electrons of 2. Let's try to find the electrons, valency electrons of carbon. Carbon is here in group 4. So we have 1, 1, and 2. Those will be the electrons on the inner layer, and it will be 2. And let's look for the outer ones, which are valency electrons. So that will be 1, 2, 3, and 4. 1, 2, 3, and 4. If we're finding the valency electrons of G, we are going to calculate from this first row, the second row, the third row, and we will just see it here. This valency electron is 3. Gallium. Let's talk chemical bonding. Now, let's say we have Na and O. First step is look at them on the periodic table. Na is sodium and O is oxygen. Step 3 is to find their valencies. Sodium has a valency of a +1 and oxygen has a valency of -2. Step 2, write their valencies, +1 for sodium and -2 for oxygen. Then swap them. This -2 will be for sodium and this +1 will be for oxygen. So this will be the new formula. Ignore that you don't have to write it when you have a +1 on top. Let's name a chemical formula. You are given a chemical formula and you are asked to give it a name. In this example, we will have to name this chemical formula. The Na stands for sodium and O stands for oxygen. Step 1, you go on your periodic table, identify the different elements and write them down. So the first one you will write is a metal. Sodium is a metal, so you write it down. The second step is to write the non-metal, which is the oxygen. Now the third step is to change the non-metal to IDE name, which will be from oxygen to oxide. and then you combine them and it will be sodium oxide. Let's try how to get the name of the chemical formula when you are given a chemical formula. So in this example, we are given CO2. Now the C, when we look at it at the periodic table, stands for carbon, and the O stands for oxygen. So step 1, we will write the first element in the formula, and step 2, we'll write the second element in the formula. And then the third step is to use prefixes. So if we have 1 carbon, we'll write it as mono. If we have 2 carbons, it will be di. The same applies to the second element. So there's a rule that says you cannot write the first element as mono, so we will leave that out and focus on oxygen. We have 2 oxygen, so that will be carbon dioxide. Di will be added. This is a second video of naming a chemical formula. Now we are supposed to name N2O3. Firstly, we have to name the first element. In this case, when you go to our periodic table, N represents nitrogen. The second step, we write our second element, which O, when we go to our periodic table, represent oxygen. Now we have them both. We have 2 nitrogens and 3 oxygens. Now we have to find the prefix. Here are the prefix. When an element is 1, we have it mono. When it's 2, it's D. When it's 3, when we have 3 of them, it's 3. So in this example, we have 2 nitrogen, so that will be written as D nitrogen, and we have 3 oxygens, which will be written as trioxide, which is D nitrogen trioxide.